Hello, everyone. You are welcome to today's lesson. And in today's lesson, it's going to be a short one. We'll be looking at the solution to the lessons on indices and logarithm. Indices and logarithm. And as you can see on your screen, this was the question. And like I've always mentioned, anytime you are asked to solve any question, the first thing that you do is to read the question and underline the salient part. So here, the salient part is for solution set. Okay, after underlining solution set, okay, which happens to be the salient part of the question, what do you then do? You go and write what solution. So here, solution is already written there. After that, you extract, okay, what you are asked to find the solution set, the equation. So the equation is extracted, yes. That's why you can see given. Okay, and obviously, we can all see that we have a log equation at hand. And if you remember in our last video, which was the video of lesson 6, okay, you were told that anytime you are solving log equations, you have two methods. Okay, the first method, what do? You make sure you have your log terms isolated, okay, or your non-log term isolated. Then after that, your log terms, which will also be on one side, you write it as a single log, then you switch to exponential equation, which happens to be your comfort zone. Then you solve. However, remember how you were told that after finding the solution, don't be in a hurry to test, to conclude. Always test the validity of your solutions, however, mentally. So here, extracted. I want to go by the first approach. And we were told that if you want to use the first approach, okay, or the first approach will be ideal when the equation comes with at least one non-log term. So here we can see a non-log term already isolated. Okay, so this will inform us that it will be ideal. It will be best for us to use the first method. Okay, so I will mention the second method, which you can see here. I will mention it when we get there and how to deal with it. So with this, you are now going to remember we said you have to isolate a log term, which is already isolated in the question. The second step is to make sure you write the log terms on the other side as a single log. So here we are going to write this as a single log. So as a single log, we have to make sure that, okay, the log bases are the same. Thankfully, the log bases are the same. Then after that, you have to make sure that the coefficients of the log terms, okay, either +1 or -1. So this log term +1, this one not, okay, +1 or -1. So it means you have to work on this coefficient. So what do? We have to take this coefficient up. So at this point, we are going to get, this must be maintained because of the form that you want. This not, you work on. If you bring the 2 up, you are going to get log a squared and it's equal to 1. Okay, and at this stage, we can comfortably write our single log. So we write your log, the base is 10, only that is not written, but simply understood to be there. Then after that, your numerator will be the log term with the coefficient being 1. And your denominator will be, okay, I mean, the log number that you are taking log of, okay, will come below. That's the coefficient, the log term with the coefficient of -1. So +1, okay, the number that you are taking log of will occupy the numerator. -1, the number that you are taking log of will occupy the denominator. So now a single log. So you switch, okay, from this log statement to exponential statement. Okay, and for exponential equation, this is what we have. Okay, so the base here is 10. So it will be 10 to the power 1. So those of you who wrote 1, okay, here, you know, it cannot be 1. When you are switching, it is this which is equal to the base here, though it's not there, but it's 10, okay, to the power 1. So that will give us what, 10 here. Only that I've written 1. You can choose not to write the 1. I wrote the 1 for you to know that, okay, we are taking the base to this exponent. Okay, now at this point, okay, what do? You cross multiply. And again, those of you who use, okay, lines to show your cross multiplication, don't do that. Avoid doing that. Just do your cross multiplication mentally. So it will be this one, okay, times this over 1 times 1, then this one times a squared, which will give us this. So at this point, what do? You are dealing with a quadratic equation, okay, where you have a quadratic term and a constant term. There is no linear term. So this is a special situation and therefore demands, okay, a special way of looking at it, okay, which will be you solving for your A. So here, I'm collecting all the terms in A on one side because I have in mind I'm solving for A. So if you move this one to this side, in my mind, I'm moving this one to this side. So that will give me 10a squared minus a squared. That will give me 9a squared. So I wrote that one first. Is equal to this. So the fact that I've written this one here doesn't mean I move to the side. Please take note. Okay, you write it again before you divide. Those of you who didn't do that, I don't know what the plan was. Then after that, you divide by 9, you divide by 9. Okay, so now you have a squared, you take the square root. And remember, I've told you, anytime you are taking square root, you ask yourself, the quantity that you are looking for, is this really positive? It's really negative? Okay, if not, then you have to take plus or minus. But here, because we are solving log equation, we know that the a here cannot be negative. So it means the a that we are looking for is really positive. So you take only the principal or the positive square root, which will give us a to be equal to what? 1/3. Then you are asked to find the true set, which some of you lost the mark because you ended not in the true set form. So you draw your conclusion in the true set. And like I've told you, let's learn to protect our marks, especially the low-hanging marks, the marks that you can easily get. Okay, so this will be it for the first method. The second method, okay, though you were advised in our lesson 6 that ideally, whenever you see in the equation 1 and log 10, this will be the best way to go. Even at this point, okay, where you had this equation, you could have solved this by factorization, and that's what I did here, just for you to know that you can as well use factorization, only that you write more if you don't look at it to be special and deal with it a special way. Okay, so now what do you do? For the other one, he said you have to make sure all your log terms, okay, I mean, all your terms are in log. Okay, but we will tell you that isolate one log term. So here, what I have here, I'm going to express it as what? A log term, and it will be, because my base is 10, it will be log to the base 10 of 10, but the base is not rated because 1 is the same as this. Okay, so at this point, this side has a 1 log term. This side must also be 1 log term. Okay, so that you can equate the numbers that you are taking log of. You can use equality of log. So how do we express this one as a single log? And that is exactly what I said here. So I won't waste time there. Okay, because I explained how to get a single log. So you go through the same and you end up getting a single log term on this side. At this point, because your coefficients are the same, okay, your log bases are the same, base 10, base 10, then it means the numbers that you are taking log of should be the same. So this implies that this is equal to this. So that's what you have here. Then you cross multiply. So you can see that at this point, you ended up getting the same equation here. So you can proceed in the same manner, okay? Or if those of you who want to use the factorization method, in that case, you have to make sure that everything is on one side equated to 0. So I decided to move the whole of this one to this side because I want to avoid my leading coefficient being negative. So that's what I did 10a squared minus a squared, which gave me 9a squared and minus 1, which gave me minus 1 is equal to 0. And obviously, if I'm factorizing this, I have to see this as difference of 2 squared. So it will be 3a plus 1, okay, into, okay, 3a minus 1 is equal to, set each of the factors to 0, and you solve for your a. And remember, at this point, you have to write it again before you divide. At this point, you don't straight away divide, write it again before you divide. So here you can see that you have two values of, okay, because you went this approach, you have two values of a, and you must always test the validity of what? Your values that you have there, which happens to be your solution. Okay, so in this case, we know if a is negative 1/3, okay, this will be, I substitute here. Here, it will not be any problem because it will be squared. I will get negative 1/3, so the whole of this will be positive. However, because of this, a cannot be negative 1/3. So it means in your conclusion, this must be discarded. However, this, okay, can take the place of what a here. So that informed the decision to conclude with 1/3. So obviously, you can see that this approach would be best. You write less, you save time. Okay. Okay, we thank God. If you have no questions, I believe I've addressed all the major concerns. One major concern was the true sets. Another major concern was when you were switching. Okay, you didn't see that though the base is not there, it's 10. So it will be 10 to the power what? 1. And when you are concluding to, you must test before you draw your conclusion. So it cannot be plus or minus. So even if the plus will work, minus will work, please take note, I've told you, you don't conclude with plus or minus together. So you must separate it. You don't write, therefore, A is equal to plus or minus. So write minus 1 on 3, okay, then, but or 1 on 3. Okay, or 1 on 3 or minus 1 on 3. Separate them, don't conclude the plus or minus together. Thank you very much for your attention and for making this class a success. God bless us all.